You can get the device perfect. The antidetect profile is clean, every value coherent, the canvas and the fonts and the time zone all quietly agreeing with each other. The proxy is a real mobile IP in the right city, behind a real carrier. On paper, the account is a different person, machine, and the connection, and then it still gets flagged, and the operator wonders what leaked, because none of the expensive parts went wrong. What leaked was him. The way he types, the way he drags the mouse to a button, the exact rhythm he does it in, the same rhythm across all 6 accounts, one after another, every morning. That is behavioral fingerprinting, and it is the layer people forget, because it is the one thing you cannot buy a fix for in a shop. I run real proxy and cloud phone farms out of Singapore, real handsets and real mobile lines, and I manage account fleets big enough that I have watched this happen more than once. Setups that were flawless on the hardware side got caught anyway. On the human side, on the part no browser profile ever touches. So this one is worth slowing down for. Third person on how the systems read behavior, and honest about what it costs you when you get it wrong. What this layer actually is. Behavioral fingerprinting is the part of detection that watches how an account acts over time, not what its device or its network claims to be. Everything in the fingerprinting world so far has been static. Your graphics card, your fonts, your IP address, facts about a machine, read once and compared. Behavior is different. It is a moving signal, collected across many sessions, describing a person rather than a device. How fast you type, how you steer a cursor when you pause. Platforms build a profile out of that motion, and it turns out to be one of the harder things to fake convincingly. Why platforms lean on it. Here is why the detection side loves this layer. Everything else can be bought. A residential IP, an anti-detect profile, a clean device fingerprint are all a purchase or a checkbox in software. But the way a real human moves through a page is the product of a nervous system, a mood, a level of tiredness, and years of muscle memory, and none of that is for sale. A platform that reads motion has found a signal money does not easily solve, which is why the operators who ignore it keep getting surprised. Typing cadence. Start with the keyboard. 2 small numbers get measured for every key, how long you hold it down and the gap before the next one. Hold time and flight time. String those together across a sentence and you get a rhythm close to a signature, the same way handwriting is. Some people hammer common words in a burst and then stall on anything unfamiliar. Some type in an even, steady pattern. The shape of that rhythm is personal, consistent enough to recognize you again, and it is quietly logged the whole time you fill in a form. Why real typing varies. But here is the twist that matters. A real person's typing is consistent in its character and inconsistent in its detail. You type the word a little differently every time. Slow down when you are thinking, speed up when you are copying, fumble a key when you are tired. That natural drift, the small imperfection that never repeats exactly, is itself the mark of a human. A genuine person is recognizable but never identical twice, and that gap is what detection watches for. The mouse gives you away, the cursor is just as loud. A real hand does not move in a straight line to a button. It arcs, overshoots slightly and pulls back, makes tiny corrections in the last few pixels before it lands, drifts off the path for no reason, hovers, changes its mind. All of that is the messy output of a real arm and eye. A script moves a cursor the efficient way, a clean line at a constant speed, landing dead center every time, because code has no wrist and no reason to be sloppy. That perfection is the tell. A scrolling and reading. A scrolling carries the same story. A person reading a page scrolls part way, stops, reads for a few seconds, scrolls more, then jumps back up because they missed something. The pace is uneven and tracks the content, slower over the dense part, faster past what they do not care about. Automation scrolls in clean uniform steps or snaps straight to an element without reading at all. The rhythm of attention is missing and its absence is visible. Touch on a phone. On a cloud phone or a real handset, the surface changes but the idea does not. A touchscreen reports the speed of a swipe, the size and pressure of a tap, the little tremor of a hand that is never perfectly still, the slight variation in where your thumb lands on the same button twice. Real touch is shaky and varied in a specific human way. Injected taps that arrive at exact coordinates with identical timing describe a finger that does not exist. The phone layer is not safer, it measures a different set of the same human noise, hesitation and timing. Then there is pure timing, the gaps between actions. A human hesitates. You pause before you hit send. You sit on a decision for a second, sometimes longer. You read the confirmation before you click it. That hesitation is not wasted time, it is thinking. A vision automation has nothing to think about, so it does not wait, it fires the next action the instant it can. A flow that moves through a sign-up with no pauses, no reading time, no second thoughts, behaves in a way almost no real person ever does. And platforms log the intervals and notice the same signature twice. Now stack accounts on top of this. The strongest way behavior burns you is not any single weird move, it is sameness across accounts that are supposed to be strangers. If 6 accounts all type with the same cadence, steer the mouse with the same curve, and pause for the same beat before the same button, the platform does not see 6 people, it sees one operator wearing 6 names. Behavior links accounts the way a shared device fingerprint does, without ever touching the hardware or the network, which is why a perfect proxy setup does not save you from it. Too consistent is its own flag. There is a second red flag that catches people who try to fix the first one. A real human is never exactly the same twice, so behavior that repeats down to the millisecond, session after session, is not a careful person, it is a machine. Impossible consistency is as loud as impossible inconsistency. A flow that takes the same path in the same time on every run has removed the human noise that would make it look real. Detection notices both the account that is too random and the one that is too perfect. Why heavy automation is easy to spot. This is the honest reason heavy automation gets caught so fast. A script is too quick, too straight, too repeatable. It never fumbles a key, never overshoots a button, never stops to read, never has an off day. Efficiency is exactly what a tired human at a keyboard is not. The more you automate the raw interaction, the more you strip out the small failures that make behavior look alive, and the easier the pattern is to spot. You do not have to make a dramatic mistake, you just have to be too smooth. Session to session variance. Real people also vary across days. You are sharp in the morning and sloppy at night, fast on a familiar task and slow on a new one. A genuine account carries that texture, good sessions and bad ones, and the variation is part of what makes it read as a real person living a life. A fleet that behaves identically at the same speed every session has no texture at all, and it is the flatness that stands out. How it gets collected, none of this needs your permission. The events are already flowing. Every keystroke, mouse move, scroll and tap carries a timestamp, and the page can listen to that stream quietly in the background while you think you are just filling in a form. There is no prompt and nothing to fail in the moment. The signal is gathered passively, the same way the static fingerprint is, and you find out it mattered only later when the account meets friction it did not expect. How it feeds the score. Behavior is rarely a hard rule on its own. It is one weighted input into the same risk score everything else feeds. A device that looks fine but moves like a robot pushes the score one way. A signature that matches another account pushes it another way. Crossed against the network and the account graph, the motion either supports the story that this is a separate real person, or it quietly contradicts it. Cross a threshold and you do not get a loud bang, you get friction, an extra verification, a quiet limit on reach, a review queue. The behavior is evidence in the case, not the verdict by itself. The humanization arms race, people try to solve this with humanization, libraries that add jitter to the mouse and random delays to the typing. It helps a little, but it is not a real fix, because patterned randomness is still a pattern. Fake noise from code has its own statistical shape, and the detector trained on millions of real humans learns the difference between messy the way a person is and messy the way a random number generator is. You can make automation look roughly human at a glance, making it hold up under a system that studies the distribution is much harder, and it is a moving target. What actually stays clean? So what actually survives this layer? Genuinely separate human use? An account a real person really operates at their own natural pace with their own hesitation and bad mornings does not have a behavioral problem to solve because it is not pretending. This is the part the tooling cannot hand you. The antidetect browser gives each account its own device story. The proxy gives each account its own network story. But the behavior has to come from a real person actually using the thing, or from operators varied enough that no two accounts move alike. That is the hard truth about scale. One person cannot convincingly perform being a dozen different humans all day across a dozen accounts without their own rhythm bleeding through. The honest way to run a real fleet cleanly is real separation on the human layer too. Real hands doing real work at varied speeds, not one operator on a macro trying to look like a crowd. That is slower and costs more, and it is the only version that holds up when the platform watches how you move rather than what you are. The honest limit, none of this makes an account untouchable, and anyone promising that is selling a story. The behavioral side keeps evolving. New signals get added. Old tricks get caught. What a clean approach buys you is that each account stops moving like the same operator wearing different names and starts moving like what it should already be, a separate real person going at their own pace. That is the achievable goal, and for accounts that also have their own device and their own network, it is enough. The operator runs these farms himself, real Singapore mobile proxies, real antidetect profiles, and real cloud phones with actual handsets behind them. So the full guides and the tested pics are at multiaccountops.com. No affiliate guesswork, just the stack it actually runs on live accounts. If you want to do this properly instead of quickly, that is the place to start. Subscribe for more honest, tested multi-account ops. Next time, the warm-up playbook. How a brand new account earns enough trust over its first days and weeks that none of this detection layer ever has a reason to look twice.